Let's solve egg cartons now. Given a number of eggs, return the number of cartons you need for that many eggs, where cartons hold 12 eggs each. Since the problem says it takes a non-negative number of eggs, you can assume that, at least in 15.1.12. When we say that, you don't have to test if it's an integer, and you don't have to test if it's negative. It could be 0, because 0 is non-negative. Coming here, what we realize is clearly it's going to do something about dividing eggs by 12. Okay, so because there's 12 eggs in each carton, but we have to take into account that if there's extra eggs left over, you have to have a carton even if there's, say, 1 egg. So it's really, if you do the integer division by 12, you have to add 1 more. And the reason you have to add 1 more, again, is, say, like, if you have 1 egg, well, 1 divided by 12 is 0, but you still need that 1 carton for that 1 egg. If there's 10 eggs, 10 divided by 12 remains 0, and still the 1 carton. Now, if there's, say, 15 eggs, 15 over 12 is 1, and plus 1, that's the 2 cartons. Correct. This mostly works. It doesn't entirely work. It doesn't work. We ran it and it failed. In fact, it doesn't work for 0, because 0 over 12 is, well, 0. And we're saying we need 1 carton. But you don't need a carton at 0. You need 0 cartons. And it's not just 0. It's every multiple of 12. 12 eggs requires 1 carton. But 12 over 12 is 1, and we're adding a second one. So the deal is this formula works except when eggs is a perfect multiple of 12. That is to say, when we divide eggs by 12, we get 0. That's how you test if eggs is a multiple of 12. Then we just want to return eggs over 12. Otherwise, we want to go ahead and return this expression. And sure enough, we passed. This works fine and dandy, but it turns out there may be a clearer way of doing this. And if you think about it, what you want to do is divide eggs by 12. Now, what you want to do here is, if that's an integer, just return it. If it's not, you want to return the next larger integer. And there's a function in math that does exactly that. It's called math.ceil for ceiling. And the ceiling function does exactly what you'd hope. Ceiling of 2.1 is 3. Ceiling of 2.9 is 3. And the ceiling of 3 is also 3. So it moves up to the next larger integer. If we run this, you see that it still works. So which of these two, and by the way, there's naturally many other ways to solve this problem as well. Of these two, which one is the better answer? I would have to go with this one. I think that it really captures more of what's happening. It's not because it's fewer letters or lines. I think it's actually simply clearer. And having said that, this is perfectly fine. They both work.